Hello class, I would like to go over 3.4 and 3.5 today. Let me share my screen with you. For 3.4, you have learned already section 3.2 and 3.3. 3.4 and 3.5 is like a summarizing what you have learned from numerical data and categorical data. So let me walk you through 3.4. We will comparing the measure of the center, and we are having symmetric distribution, skew distribution, and how to compare the measurement between these two distribution. It looks like for symmetric distribution and skew distribution, we are having the following. We have three characteristics: shape, center, and spread. For symmetric distribution, all the time you need to compute mean and the standard deviation. And for the skew distribution, you need to compute median and IQR. IQR is interquartile range, which is the middle 50% of the whole data. So let me show you this. It looks like you are comparing, symmetric and skew. How do you compute the center, the spread? And we are having the following table for you to look at. For symmetric, you compute mean and standard deviation. For skew distribution, you need to compute median and IQR. That's it. How to compute IQR? You have to take Q3 minus Q1. And to find standard deviation, you have to compute by using the formula from the previous section, or you can run StatQuant. I don't mind. If you run StatQuant for either skew or symmetric, you can right away compute got solution for mean, median, standard deviation, and IQR, which is I already demonstrate in a separate video. Please check it out, StatQuant from chapter 1 to 3. You will see how do I run it. And you can run that for your test if I asking these questions. For the following example, so one of the author creating the data set for the songs for his MP3 player, and he want to describe the distribution of the song lengths. Usually you all know that all the songs is last like about 3 to 4 minutes, and really rare that the song can last really like 10 or 20 minutes, right? So if you can imagine that, you can see that it looked like distribution for this example would be skew, and but you can jot down, you can pause this video and thinking about that questions. So I'm having the following data. For the shape of the song, as I just analyzed, it should be skew, not symmetric. And because it's skew to measure this data, so for the center, you need to find median. And for the spread, you have to compute IQR, which is number 2 right here. So right here is the picture that we just imagined. Not all the song will take like about less than 100 seconds, and more is would be in the middle. It looked like a skew right here, skew to the right. And so they estimating, when you estimating like that, because you don't have the actual data, so we can just estimate following this picture, and look like the median of the length is 2 to 6 seconds. It's about 3 minutes and 46 seconds. The interquartile range, they will find the Q3 minus Q1. So in order to run this data, we have to spend time type in the StatQuant to get the data, or you can draw out directly from the ebook and run StatQuant to get the solution. Right now, you don't have that. You don't have to worry about this, because on the test I will give you like about 10 or 20 data for you to run. And again, how to run it, you need to check out my video, other videos, okay? And again, go back to the center between symmetric and skew. We're having mean and median. Right here, you don't have to memorize this, but just need to memorize is for the mean. Actually, for symmetric distribution, you can for the center of the data, you can either compute mean and median. And also for symmetric distribution, for the spread, you can either compute standard deviation or IQR, doesn't matter. However, but for the skew distribution, you must follow it. You must figure out the typical value by computing median and computing the spread by finding IQR. That is a must. You can jot down what I just said by, write somewhere for you to keep in mind, or you can go back to previous slide. It's already give you over here. For symmetric, you can using mean or median, standard deviation or IQR, but for skew you have to follow only median and IQR. So look at this example. They're talking about the fast food restaurant has 5 employees and 1 full-time. So you look at the income that they make. Most of the employee can make only 16,000 per year. If it is like $7 per hour, then it will be the money. And the owner will make like about 100 per year, 100,000 per year. And if you jot down the data, you can see that this will be skew again, right? So right here, they want us to find both mean and median so that we can compare which will be the correct one. For the skew all the time, median will be the correct one. But for symmetric, it's okay to compute either mean or median. So when we computing and we like have the following picture, we done computing. If the mean, you add all of this data, 5 of employee and 1 owner, you add all of this together by 16,000 times 5 and plus 30,000, plus 100,000, you found the mean is about 30,000. Which is not correct because it looks like it's outside of the actual value. Like majority of them will make 16. So the best way for skew, you have to find median. That is the reason why. So you have done comparing already, and over here they're talking about comparing between two distributions. So this is look like a summarize, right? So always use the same measure of center and spread for both distribution. So if you are comparing two distribution, we rather uh, measure only like the same measure of the center and the spread. I'm talking if we compare two skew distribution, you have to rather using 5 median for both set. But if it's one set is symmetric and one set is skew, you rather find the center for skew, which is 5 median for both. Because symmetric distribution, median and mean works for both. So we put priority for skew data to be more accurate for both. And the same thing with the measure the spread. If one of the distribution is skew, you should use IQR for both. And here it said use median and IQR to compare for both. So here's one of the example. Look at this two distribution. You notice the spread is look. This one is the spread is very short, which is good. It looks like they stick to each other, but look at this one. They have more data in between of each column. It means the spread for this picture is big. So compared to this blue and green color, the fat and the thick, the thin one is run faster. And the median is they both like the median for the blue one is 266, which is more time than compared to median of 155, right? So in here is the conclusion. So they both kind of right skew or symmetric. So we priority for skew, so we rather use median for both and IQR for both. And like I just analyzed by looking at the graph, look at the Olympic women runner. Olympic runner is run faster because of the spread between the data. As I look at this, is very small, and this is thick, so this is slower, this is faster. So this is the end of the video for section 3.4. I hope you understand it quickly. It looks like for this 3.4, you are learning about comparings between two distribution, and we care about the center and the spread only, right? And for section 3.5, for section 3.5 again is it's a summary. However, you learn a bit more about graphing, a new graph to help you analyze better for the skew data or symmetrics here. The name of this will be box plot, and you will learn about 5-number summary. So first, let's take a look at outliers. Outlier is the extreme value data, which is this outlier will screw off the whole data if you don't cut it off. So the outliers will be the value that is too far away from the majority of the data set, or either the right or the left side. Right here, you find, in order to find outliers, to compute by hands, we have to compute the fences. If we run StatQuant, you don't have to do this step. Okay, and again, in this class, is the online class, I don't expect you to compute by hands a lot, but you rather know it, how to do it. I will, I did show you the video already, and you can check that out. Or you can also check it out, the video from Pearson. They do have the StatQuant video separately for chapter 3 too. So to find the outlier, again, I go back to this section. You have to compute this. If you compute by hand using Q1, which is the median of the first half of the set, minus 1.5 multiplied with IQR. IQR is Q3 minus Q1. Q3 is the median of the lower half. So this is how to compute by hands. And again, you don't need to compute by hands on your test. So after doing all of this process, they will figure out the outliers. Here is one of the examples to figure out outliers if this city has it. So the first and the third quartiles. So the first quartile we call Q1, which is 59, and the third quartile is Q3 is 70. So now we're going to use these two values to compute the outliers. Again, they apply the formula that they are having 42.5 and 86.5 are the fences. So all the value below 42.5 or above 86.5, they are considered outlier. So outlier is we find outlier because we don't want the majority of the data it's falling, drag the outlier within, so it's make our guess worse. So that's why we have to cut off the outliers. The box plot is one of the shape of the graph helping us to analyzing data better. So this box plot helps us to visualize certain summary statistics and show where the bulk of the data lies in. So, and the box is drawn from Q1 to Q3 with a line for the median inside the box. So the median in this case will be, we call Q2. And when I do have whisker, the whisker are drawn to the most extreme value within the fences. And all the potential outliers are marked with an asterisk. The box plots work best for unimodel only. So here is the box plot is look like right here. You look at this picture, the box plot, so they shaded in blue color and the light in the middle, which is the median will be Q2. Q1 will be this line. Q3 will be this line. The whisker will be from here to there. So the lowest value, they will stop right the lowest value from the observed data. And this value is not from the observed data, but this is the fences. So I can call this will be the fence, the upper fence, and this will be the lower fence. Because they don't have any value from the left side of the lower fence. There's no outlier on that side, but we do have a lot of outliers to the right side. They are about like 6 of them. So if we cut this off, so this value, this data won't affect the main data, the majority of the data is in here. And we call names, say minimum, Q1, median, Q3, and this largest, this farthest outliers right there, we call, combine all of this, become 5-number summary. That is how you label on the graph with 5-number summary, or listing them out. So look at this graph, we can see the minimum value is 49, and the median is 64, and the potential outlier, they said it's 5, but it's, to me it's look like 6. So 1 right here, 3 right here, 1 here, 1 there. Anyway, maybe here is only 2. So like about 5 of the outliers. You don't have to worry about TI-84 since you're not using TI-84 in the class. You only use StatQuant, so you can ignore this. For those who are using TI-84, you can apply this. These are the 2 examples, 2 distribution, kind of symmetric, and the shape. We can, so all the data will be given, and when you run StatQuant, that will show you 2 different box plot for you to compare. For this one, so one is for San Francisco and one is Provo City. So we're measuring the degree and the spread between them. Looking at this too, you can notice the spread for the blue one is thicker. So it means it's not close at the San Francisco one, right? So this is small spread, the blue is small spread compared to the yellow. Now is the box plot of these 2 distributions. So look at the box is very long right here, is telling you the spread very large. And over here is smaller. So we like smaller because look at, we can determine majority of the degree, the temperature in San Francisco is really balanced, like really the same. Over here they spread a lot, so it's hard for us to predict. Excuse me. And the 5-number summary, you look at here, like I mentioned, 5-number summary will be the minimum value from the observed data. Q1, a median, Q3, you can compute by using StatQuant for this. The maximum will be from the observed data. So everything we're collected over here will be 49, the minimum, 59, Q1, 64, Q2, which is median, Q3, 70, and this value will be 97 from the observed data. So we call this will be 5-number summary. All right, class, if you have questions still, please email me. And yes, please email me. Thank you very much. We're done for the lecture today.